Hello students, this is a video on the topic tests for quant available in the Bodhee Prep app. So these tests are to be attempted once you've done the basic concepts of a topic to ensure that you're able to do those questions in the exam as well. With every test, there is a video which gives you the solutions and a brief analysis of what would have been a good attempt for that test. More than 200 such topic tests are available on the Bodhee Prep app. The link for the app is in the description below. So make sure to download the app and make the most of these tests. This video is on the topic set theory. This is test number 3 that we are discussing. Overall, it was a moderate level of difficulty test where about 6 questions net correct. Out of 10 would give you 95 plus percentile, and the attempt time for these 6 questions, finding and doing them, would be somewhere around 20 minutes. If we look at the questions, question 1 says in a company 78% of the employees are in operations, 69% finance, 87% in HR. It is compulsory to work in at least one department. What is the maximum percentage of employees that could have been working in all 3 departments? If the number of people working in exactly one department is X, exactly 2 departments is Y, and exactly 3 departments is Z, we can say X plus Y plus Z will be 100 because everyone has 100%, because everyone has to work in some department. Also, X plus 2Y plus 3Z will be the count of all the numbers in the Venn diagram that we draw. So this will be 78 plus 69 plus 87. 8, 9, 17, 7, 24, 4 carry forward 2. 8, 10, 16, 22, 34. So if we subtract this equation from this one, we'll get x and x cancel. 2y minus y plus 2z is equal to 134. We want to maximize the number of people working in all 3 departments. We have to maximize z. So let us put y is equal to 0. Z will come out to, or 2z will come out to 134. And therefore, the maximum number of people working in all 3 departments would be 134 by 2, or 67 becomes the answer. I think the standard process question, so it's a moderate level of difficulty, about 2 to 2.5 minutes to solve. Again, this is a follow-up of the previous question. Says in a company, 78% employees are in operations, 69% in finance, 87% in HR. It is compulsory to work in at least one department. What is the maximum percentage of employees that could have been working? In a company, 78% of employees are in operations, 69 finance, 87 HR. It is compulsory to work in at least one department. What is the minimum percentage of employees that could have been working in all 3? If the number of people working in exactly one department is X, exactly 2 is Y, exactly 3 is Z, we can say the total number of people should be all the people in the company, that is 100%. And X plus 2Y plus 3Z, number of people working in one department plus twice of number of people working in 2 departments plus thrice of number of people working in all 3 departments will be 78 plus 69 plus 87. This comes out to 234. Subtracting the first equation from the second one, x minus x, 2y minus y is y, 3z minus z is 2z. This is equal to 134. Now we have to minimize z. We know that if x is 0, y plus z will be 100 from here. If we substitute that, y plus z is 134. The maximum value y plus z can take is 100, and therefore the minimum value z will take is 134 minus 100, which is 34. That becomes our answer. In this kind of question, what we can also do is we can take the complement of the sum of complements of each term. This can also be used directly. So this is complement of 78 is 100 minus 78, 22, 31, 13, 2, 3, 5, 6, 6. 6. Complement of 66, 100 minus 66, 34 becomes the answer. This or that, I think moderate level of difficulty, about 1.5 minutes to solve, especially because most of this we've already done in the first question. In a group of people, there are 13 who like apples, 9 bananas, 15 carrots, and 6 dates. A person can like more than one kind of fruit. Each person who likes bananas also likes exactly one of apples or carrots. Each person who likes carrots also likes one of banana and date as well. Now there are 15 people who like carrots. Each person who likes carrots also likes a banana or a date. There are 9 people who like bananas. There are 6 people who like dates. Therefore, we can say out of the 15 people who likes carrots, carrots and bananas will be 9. Carrots and dates will be 6. People who like bananas like either carrot or apple, exactly one of them. We have already taken this number to be 9, so this number becomes 0. Now, 15 people who like carrot have been counted, 6 with dates and 9 with bananas have been counted. 13 people who like apples are remaining. Obviously, the people who like apple cannot be the ones who like carrots and bananas, because the people who like bananas like exactly one of these two. So this cannot be increased. But what we can do is, people who like carrots and dates might also like apples. So 6, this number remains 6 because dates was 6. Now the third group will be number who like only apples. There were 13 people who liked apples, out of which 6 have been counted. So 13 minus 6, 7 remain. And therefore 9 plus 6, 15 plus 7, 22. If we have 22 people, we can distribute all of them. 9 people like carrots and bananas. 6 people like apple, carrots, and dates. 7 people like only apple. So banana will be 9, carrots will be 15, apples will be 13, dates will be 6, and all the constraints will be met. So minimum 22 people are required for this to happen. I'd say moderate to difficult question. The distribution can become a little difficult to do. About 2 to 2.5 minutes to solve. There are 1200 respondents to a poll, each preferring their preference, each sharing their preference for candidates ABC. 54% A, 48% B. 54A, 48B, 48B, 42C. 30 favor both A and B, so sum of this will be 30. What is the largest possible number of respondents favoring C, but not C and B nor C and A? The largest number for A and B can be, for if we put the common of AB here 30, here we'll have 24 left, because we want A and C and B to be minimum, that is 0. Here we'll have 48 minus 30, 18 left. This becomes a total of 24, 30 and 18, which is 72. But the total for this entire Venn diagram should be 100, because everyone had to choose one party. 72 minus 100 is 28. So there has to be a minimum of, maximum 28 here is possible. To complete C, what we can do is you can put 14 here and take 14 from this and put it here. So this becomes 30. A is 54, B is 48, C is 42. And we get people who support C as 28%, not C and B, not C and A. 28% of 1200 is 28 upon 100 to 1200, which will give us 240 and 96. 336 as the answer. So that becomes the largest possible number for C. Otherwise, there can be a higher overlap for C and only C will decrease. I think difficult question, about 2 to 2.5 minutes to solve. In a class of 30 students, 2 students did not borrow any book. So 2 students borrowed 0 number of books each. 12 students borrowed 1 book each. 10 students borrowed 2 books each. The rest of the students each borrowed at least 3 books. 3 or more. If the average number of books borrowed per student was 2. What is the maximum number of books that a single student could have borrowed? Let us keep that single student separately. Therefore, remaining students that we have are 12, 10, 22, 23, 22, 25. 5 are left. We will give them the minimum number of books. Apart from these students, the remaining have at least 3 books, so they will borrow 3 books each. This one person will borrow X number of books. So the number of books borrowed will be 2 zeros are 0 plus 12 ones are 12 plus 10 twos are 20, 5 threes are 15 plus X. Total number of students is 30. This should be the average number of borrowed books, which is 2. So this will give us 32, 47. 47 plus X is equal to 60, or X will come out to 13. Since all of the others have borrowed minimum number of books, the person remaining will borrow the maximum number of books, which comes out to 30. I think a cross between average and set theory, easy question, about 1.5 minutes to solve. All of the students of music high school are in the band, the orchestra, or both. Band, orchestra, or both. 80% of the students are in only one group. Therefore, 20% will be in both the groups. There are 119 students in the band. 50% of students are in the band only. And therefore, we can say number of students in the band is 70%. 50 plus 20. 70% of number of students is 119. Therefore, 0, 0 cancel. 7 ones are 7. 17. N will come out to 170. How many students are in the orchestra only? Since we have 50 here, 20 here, 70, the remaining 30% will be orchestra only. So my answer becomes 30% of 170, which is 30 by 100 to 170, 0, 0 cancel. 317s are 51, option B. Again, I think easy question with the first line has to be cracked. From there, not difficult to solve, about 2 minutes to solve. In a class of 120, 80 can speak English, 70 can speak Spanish, 60 can speak French. Every student in the class can speak at least one of the languages. At least how many students in a class can speak all the 3 languages? So if X is the number of people who speak exactly one language, Y is the number of people, students, who speak exactly 2 languages, Z is for exactly 3. We can say X plus Y plus Z is equal to 120, and X plus 2Y plus 3Z, counting this will be counted once, these will be counted twice, this will be counted thrice. This will be 80 plus 70 plus 60, which will be 210. Taking the difference, Y plus 2Z is equal to 90. So from here we can say if X is 30, Y plus Z will become 90. So from here Y plus Z could be 90, which means Z will be 0. Minimum number of people who are speaking all the languages, this can go down to 0. How we can get this distribution is for English, Spanish, and French. We put a 0 here. Since Y we are taking is 90, equally divide 30, 30, 30. English is a total of 80, so 20 comes here. Spanish is 70, so 30, 30, 60, 10 comes here. This is 0. English 80, Spanish 70, French 60. 30 plus 20, 50 plus 30, 80 plus 90 plus 120 is also the total number of students. Hence, 0 is the minimum. Easy question because of the numbers primarily, about 1.5 minutes. In a group of 200 students, 80 students like maths, 75 like chemistry, 60 like physics. The number of people who like math and chemistry only is 10 more than the number of people who like chemistry and physics only. The number of people who like only one subject is 100. If we draw a Venn diagram, for math being 80, chemistry being 75, physics being 60. Only math and chemistry is 10 more than only physics and chemistry. If the number here is x, the number here will be x plus 10. Also, ABC has to add up to 100. Now we look at the sum of all the numbers. ABC is 100. The sum of all the numbers here will be 80 plus 75. Suppose this is y, this is z. 80 plus 75 is 60 is equal to 100 plus twice of y plus x plus x. 2x plus 10 plus 3 times z. This becomes 215. 115 is equal to twice of y plus 2x plus 10 plus 3z. If you want to minimize the number inside the Venn diagram, we'll try to maximize z. Also, this 20 will always be there irrespective of value of y and x. We subtract it here, so we get 95 is equal to twice of 2y plus 2x plus 3z. If you want to minimize the total number inside, z has to be maximized. 95 is not divisible by 3. The closest multiple of 3 to 95 is 93. So what we do is, we put y as 1, x as 0. And therefore, we'll get 93 is equal to 3z. Z will come out to 31. This becomes 31. X is 0, so this is 10. This is 0, and this will be 1. In this case, the sum of numbers in the Venn diagram will be minimum. And the sum will be a plus b plus c is 100. 31, 41, 42. So 142. Out of 200, only 142 people are in the Venn diagram. Therefore, minimum number of people who like. This will be the minimum number of people who like at least one subject. 142. Again, in terms of level of difficulty, it's a difficult question. Solving time may be about 2 to 2.5 minutes. In a group of 200 students, 80 like math, 75 chemistry, 60 physics. Number of people who like math and chemistry is 10 more again. A similar diagram. Math 80, 75 chemistry, physics 60. This is x plus 10. A, B, C is 100, Y, Z. So like the previous case, I'm writing A plus B plus C plus 2 times of Y plus 2x plus 10 plus 3z is equal to the sum of 80, 75 and 60, which comes out to 215. ABC is 100. And therefore, we are left with 2 into y plus 2x plus 3z is equal to 215 minus a plus b plus c 100 minus 2 10z, 2 into 10, 20. So twice of y plus 2x plus 3z is equal to 115 minus 20, which is 95. Now what we want to do? Maximum number of students who like exactly 2 subjects. Here we can try to maximize y. 95 is not divisible by 2, so we'll give z a value of 1. So 2 into y plus 2x will become 92, which means y plus 2x will become 46. So if we make y as 46, x as 0, this is the distribution that we'll get. In this case, the max number of people who like exactly 2 subjects will be 46 plus 10, which comes out to 56, and that would be the maximum. In terms of level of difficulty, again, because maximum minimum, I think difficult question. So solving time may not be very high because we've done most of the calculation earlier. A survey on a sample of 25 new cars being sold at a local auto dealer conducted to see which of the three popular options, air conditioning, radio and power windows, were already installed. The survey found 15 had air conditioning, 2 had air conditioning, power window, but no radios. Okay. So if you maybe draw a Venn diagram, air conditioning, radio and power windows. 15 had air conditioning, 2 had air conditioning and power windows, but no radio. 12 had radio, 6 had air conditioning, 12 had radio, 6 had radio and air conditioning, but no power window. 11 had power windows, 4 had radio and power window, 3 had all three options. So for radio and power window only, we'll be left with 1. Since this is 15, 6, 3, 9, 10, 11, 4, 15, 6, 3, 9, 1, 10, 11, 12, 2, 3, 5, 1, 6, and 11, 5. What is the number of cars that has none of the options? Total number of cars having at least one of the options is this entire thing 15 plus 5, 20 plus 3, 23. Total cars were 25. So 2 of the cars have none of the option. D becomes the answer. Again, this is the previous CAT question, level of difficulty. Maybe breaking the question down into whether we use the Venn diagram or the equation might be the challenge. After that, about 2 to 2.5 minutes to solve. If we look at the overall paper, we are looking at about 6 questions in 20 minutes. My 6 questions will be 1, 2, 3, 5, 6, 7, which are the. I have done this kind of question earlier. Therefore, 1 and 2 I am attempting. This was, I think, an easy question. Distribution was required, so I'm attempting this. This, I think, could become difficult because the distribution was new in that sense. This was easy, one of the easier questions in this set. This also, I think, was a specific or a definitive answer, so would be doing it. The numbers were easy, therefore attempting the question. I think maximum minimum questions are always difficult, therefore 8 and 9 I'm not counting. Since I have my 6 questions, so 10 also can be looked at if you wish. For me, 1, 2, 3, 5, 6, 7 will give me my 6 answers correct.